the CEO and co-founder of SmartCat, and Nikola Jankovic, software engineer at SmartCat. Their mission is to make a difference with data. Their goal is to drive positive impact through data. They wish to unearth crucial patterns, address global challenges, and take part in social change. In this talk, they will be speaking about AI enhancements you can add to your e-commerce website. Their discussion will encompass the specific challenges these enhancements address and the tangible outcomes they can deliver. The heart of their discussion will revolve around semantic search, a sophisticated technique that interprets user intent and the contextual meaning of terms to fetch more relevant search results. They will also offer a live demonstration utilizing real-world data and an authentic vector database. Nenad, Nikola, the stage is yours.
Thank you. Hi, everybody. Welcome to our talk. So I want to start with one question, especially in the lights of OpenAI development in Silicon Valley. Are you optimist? Do you think that AI technology will improve our lives and we will live better? Or you think that you are pessimist and you think we are moving too fast and all CEOs of AI companies should be fired right away? Optimists, can you raise your hand? Pessimists? Okay, divided audience. I'm optimist, at least at the end of the day. Even though tools are being developed right now and a lot of things are happening in our space, I think eventually a lot of boring tasks will get automated and we will eventually live better lives. Regarding our company, SmartCat, we came up with this sentence, brain-powered AI company. I think it's important, and Cassie on keynote said that pretty much everything that human can do, AI will automate, and I think this brain-powered component is really, really important. We are developing AI solutions for other companies, and we work in different verticals, and we are solving different problems. Regarding today's agenda, we'll talk a bit about AI enhancements, or how I like to call them, old way of doing AI. Then we will mention a few tools that emerged, and we will cover semantic search as a new improved way how you can search, especially e-commerce websites, because they have a lot of items. We will cover, and my colleague Nikola will cover a couple of tools which are important to make this happen, and we will end with demo and QA session. So let's begin. I think everybody in this room knows about e-commerce, but I wanted to mention that for us, connecting items and users is how we see marketplace, the first marketplace, but also e-commerce. So also Netflix-like applications, movies, videos, etc. we treat as e-commerce because problem space is pretty similar. And I want to cover a couple of use cases which you can add to your e-commerce website, which are AI or analytics based, to fire up discussion. So these are 5 use cases: item categorization, personalization, item ranking, similar items, and at the end, user segmentation. So let's start. Regarding item categorization, I think database of items and articles is growing, and you need help when you are dividing these items in different categories. If you are doing that manually, this team will grow, and you are prone to human error. So you can train AI algorithm, which will be like assistant to person who is doing this category division, and they can help by giving hints and automatically placing items in different categories based on images and based on description. This will improve performance of your team, and eventually it will improve search because your category placement will be better. Next thing is personalization. I think everybody knows recommender systems. They are here for a long time, and me personally, I like when machine is giving me suggestions. I'm doing a lot of decisions during the day, and sometimes I like when machine or application is doing this decision making, what I need to buy, watch, listen for me. Sometimes I get surprised, which is a nice thing. because we are all creatures of habit. So I think at the end, the recommender systems are giving you better user experience, but also I think they are increasing chance to either sell or convert some goal that you have on your application. Next thing, same like Google search, ranking is really important because we don't have time to move to the next page of search results. So I think if user gets in first 3 results what he wants to buy, he will stay. If not, he will move to another website, especially with this young generations, TikTok generations. I think their attention span will get even more narrow. So having a good ranking is really important for e-commerce website. And I think main reason of churn of users and going to somewhere else is bad search and not being able to find what you're looking for. Next thing I want to mention is similarities, is similar items. In ranking, I am choosing one item that I want to buy, but I want to have options. And when I move to this item description page, I want to have a couple of more options, you know, so it looks that I'm in control and I have some other options to choose from. And this improves user experience, but also there is higher chance of a successful sale with similar items. And last that I wanted to cover is user segmentation. Your sales and marketing team can do their job much better if they have demographics data, but also if they have groups of different users, and then you can provide personalized content to different groups, which is really powerful thing, and your sales and marketing departments will love you if you do some kind of segmentation so they have better input. So definitely these marketing campaigns and sales campaigns can have much better conversion. But why I mentioned at the beginning of presentation that I think this is the old way of doing AI, even though I know that a lot of e-commerce websites don't have a couple of solutions that I showed here. Last year, OpenAI made a revolution, in my opinion, to show how AI solution can be demoed. So a lot of different tools emerged. Now we have vector databases. We are transforming information into vectors. So we have better search experience. We have a couple of frameworks which are making it easy to build AI solutions. Also, large language models helped a lot to explain to machine what we want to pull from some kind of database. I listed here a couple of important tools. I listed here Vector Discovery, one vector database that we worked on, and you will see a demo at the end how semantic search can work. But this opened up a possibility for any marketplace, any e-commerce website to have a better user experience when people are searching for items. And my colleague Nikola will take over to give more technical details about these tools and semantic search. Nikola, floor is yours.
Thank you, Nenad. Okay, let me just see if this is going to work. Yep. Thank you. Hi, everyone. I'm going to be talking about semantic search and how we can make it easier and do it much better with the power of vector databases. Before I start, can you raise a hand who knows how to spell sophisticated, complex business without autocorrect? Okay, not a lot of you. I misspell a lot, and I think a lot of our users can misspell as well. So let's give a scenario where we have a hotel app which have apartments, and our user goes in, he writes business suite really quickly, and he just search. Okay, what do I get? I get no results. I guess your app probably doesn't have business suite, even though they misspelled business. They have no results. What happens? Our user gets to another platform, he types it correctly for this time, and he gets it. We just lost a user. Another more complex problem that our users face, myself as well, when you want to find something specific. For example, we want to buy a dress for our girlfriend because we're having a beach wedding, and we're not sure where to look. We Someone might have millions and millions of addresses in their e-commerce platform, but we're going to go to Google. We're going to search cute dresses for beach wedding, okay? And then it's going to search, what are you going to find? We're probably going to find someone that has already did this, marketed, get the ads, and they're going to sell it to them. We might have millions of dresses on our site, but they're never going to get this. What if this problem could be solved with our site? What if we could have a search that does search with intent, that we could type just the same as we type it in Google and get the results that we want? And we're going to talk about that. Before that, I want to introduce myself. I'm Nikola Jankovic. I misspell a lot, but I'm also working on a vector database in the SmartCat that's actually going to solve that problem. This is one of the reasons why I'm actually here, because vector database is something new. It's a new technology, but I think it's going to revolutionize a lot of sites and a lot of databases and our data inputs to get a much better user experience, and we're going to increase our revenues and sales, because we're going to provide a much better user experiences for our users or customers. Okay, now, before we start, we're going to have a simple, I'm going to explain a bit what semantic search is. Difference between semantic search and maybe keyword search is when you search for a person with the name John, we're probably going to get John, only John's there, and that's all the results. With semantic search, it's going to try to find meaning behind your search, and it might even give you John with H, or may give you Jonathan or Joe. It's basically trying to understand what are you trying to search for. There's a bunch of solutions and tools that are traditional for semantic search. The first one is probably natural language processing, which is exactly that. We're trying to make our system understand what the language is and work with it. There's contextual analysis, basically trying to understand what the context is. For example, I'm making my way downtown, or I'm making dinner. Those are they're the two same words, but make is a different context. Also knowledge graphs, which are a bit older. They're used to basically represent entities in our system. For example, London is a city, which is in England, and England is in Europe, it's a country. So when we search for London, we might get some similar items around that graph. Of course, as Nenad said, everything is AI now, and machine learning is used in semantic search as well. There are pre-trained models which do this extremely well, something like GPT models, which can basically predict what you want when you ask it. And also synonym concept recognition, which basically you just give it all the synonyms of one word, and we're going to expand our result set because it knows all the synonyms of that one word in our query search. Okay, now that we know what semantic search is, some of the basics, we can go to vector databases. What's this new tool set and database that we can use? Before we can go with vector databases, we need to understand what a vector is. It's physics, mathematics, lines, design, what's a vector? And computer science, it's just numbers. It's basically floating points, but it's 1, 2, 5.6, whatever. And why are they important? Because machine learning models work really well with arrays of vectors. And not any arrays, but n-dimensional arrays, which are basically huge numbers, but they do it really well. This is important, and I'll show you on a concrete example later. So we got vectors, we got a really efficient storage, and we get a vector database, plainly. Okay, but why are they important? Why are they emerging? What's the point of vector databases? Well, vector databases are trying to solve one simple thing, and that's similarity search. Pretty similar to semantic search, basically. So now we're going to compare what are these traditional semantic search, how it does it, and what vector semantic search solves with that. NLPs, or if anyone did natural language processing, or even language, it's hard. It's pretty hard. There's a lot of tools that helps, but it's pretty hard. Like day-to-day person communication, hey, we also, even in day-to-day are talking, we miscommunicate, don't understand the context, and training a computer to do it is pretty hard. Vector databases fixes this problem, but there is no training as everything is a vector. There is no need for a huge data set. Same for knowledge graphs. They're basically unreusable when you make it for one app. If you have a medical app and you create a huge knowledge graph about all the anatomy, brain, whatever, and you connect it, you can't create a legal app with it because it does not know anything about it. While again, the data modularity with vector databases, it doesn't matter because in the end, everything is a vector, and we can give it a lot of inputs as audio, text, even video. And it can create a vector which is easily understandable by the vector database. Machine learning models, when using them, they are extremely. All machine learning models which we would use for semantic search needs to be trained non-stop to have the best results. They need to be constantly retrained with the newest data to understand when the user asks what they want, to give it that result that we want. While the initial cost with vector databases is we use the initial machine learning model to create embeddings or to vectorize our data, and that's going to help us find the data. In an example in the next slide. The other thing is, working with the traditional semantic search, we need huge data sets, huge. You want to have the data set to learn English, you're going to have a huge data set just so the machine learning model can understand English. While in vector databases, because the underlying pre-trained models that we use to vectorize are so good now, GPT, Hugging Face models, you basically don't need a huge data set. You only need a data set you want to use, which could be 10,000 documents or even 1 million documents. It does not matter. It scales linearly. Okay, now, why vectors are important and how does the vector database work? This is simplified search, simplified explanation how vector similarity search works. But it's pretty simple. It's 2D. In the first column, we have images, documents, text. We give it to the second column. The second column is basically a machine learning model, a pre-trained, so GPT model. And it vectorizes everything, creates vectors from that data. Those vectors are mapped and given to the vector database, and the vector database plots it in a 2D graph. Pretty simple to understand. Now, when we want to give a search query to it, so cute dresses for a wedding, beach wedding, we give it to the model as well. The model also creates a vector, plops it in the vector database, and our algorithm inside the vector database is, all right, these two things are pretty similar, let me give those results to you. Okay. Sorry. That seemed pretty simple. Basically, it's a plot, the graphs, they're similar. The algorithm, everything behind it, and the actual dimensions of the vector databases are huge, and the semantic leaps that it can create from those similarity search is amazing, which we'll show in a demo. I'm only going to be talking about one simple thing, because similarity search, the vector databases provide abstract all the semantic search for you, which basically the only thing you need to worry about is data quality, as in every database. So privacy and security is probably one of the most important things that a lot of people brush off working with anything, but I think it's really important so we don't give a password of a user to the database and then we, by chance, get it back when the user searches for it, or GDPR policies. Almost all vector databases deduplicate, handle null values extremely well, so we don't, there's technically no need for that, but if we do it ourselves as well, we will create a better database that's going to be more precise, and it's going to take less time to ingest all the data we use. Also, have a consistent data format. If we're going to use only text to be able to search, only give it the text documents in a format as JSON newline or Parquet. And have relevant data. Relevant data is basically if you want to be able to search by name and description only, we only give it the data that we need. So just give it the name and the description of those products that we want to be able to search, so we don't create unusable data and create a bigger database than we need to. Try to remove bias from our data, which is a bit hard to explain, but with an example. For example, we want a model that's going to give us the best programming language for our project when we explain it. We're going to give it the data sets from the 90s. It's all Java, bits of Java, a lot of C, a lot of Delphi, a lot of Pascal, maybe even Fortran. And when we ask it, it's going to give us, all right, you probably should use Fortran for this, but this is wrong. It's 2023, no one uses Fortran. I hope no one uses it anymore. So we try to remove bias and normalize the data. We give it and get the latest data, most up-to-date data, so we can get the best results. Sorry. Okay, now let's recap. Nenad has talked about AI enhancements the old way, as he said. how we do. Some of these enhancements might not be even on all e-commerce platforms, but some of the new things, the new tools that have emerged will help us basically implement something that's extremely complex, that's been doing for decades to solve this issue, starting from rule-based if-elses in semantic search and natural language processing to getting to vector databases where you basically just have a database now. You don't have to think about retraining models or any of that. You just give it the model, it gets ingested, that data is vectorized, then you use a similarity search, give it an input, and it gives you back all the similar products. Data quality, the important thing when handling vector databases, how to handle it, what to look out for. Now, we're going to have a demo, not a live demo, sorry, from our friend from Vintage Discovery. It's Nicholas Goodman, and he has prepared a demo all the way from America, which he will show all the problems I have shown you and some of the things that Nenad has also shown us, what a vector database can solve. So, good production, please play video.
All right, well, let's start with just how semantic search platforms actually have pretty good standard keyword searching as well. So let's say that the corpus or the set of recipes may also have, the veggie and lasagna, the two keywords that we're talking about, already present. So first thing to know is that with the semantic platform, because semantically identical words are very close semantically to themselves, you're going to get great standard keyword searching matching as well. So we've got veggie lasagna, veggie packed lasagna. It even has made one semantic jump from veggie to vegetable lasagna. So starting with is you get great semantic keyword searching to start with. Second, if you're doing more than just semantic search, and you're using a system such like Vantage, you'll actually be able to actually do traditional keyword type filtering as well. So categories like main dishes, other Boolean filterings, ands, or to be able to actually limit to a certain subsection of your catalog. So for instance, veggie lasagna, we don't really need it to search the cocktails and desserts area. We are looking for main dishes, and we get very similar results. Okay, now let's take our first leap into an intent-based or sort of semantic search. So let's say we have a party that we're trying to plan for, that we're going to want to have some beautiful and very shareable desserts present. And really what we're thinking is, we want to share these on Instagram. We want these to be Instagram worthy. Now, these particular recipes have not actually tagged themselves as Instagram worthy, right? The concept of beautiful and shareable recipes and things that look gorgeous to be able to share on social media are not necessarily part of the descriptions of these items. But our system needs to be able to understand your intent. I'm wanting to share these. They need to be beautiful to be able to provide good results. So our Instagram-worthy search came up with a lot of great relevant results. We've got owl cupcakes, which look stunning, tie-dye emoji cupcakes, something that are these. All of these look fantastic. And these semantic jumps can provide amazingly relevant results to your users. For instance, how did Nutella popcorn puppy chow come up as a result here, right? So it doesn't actually mention Instagram. It actually just has its normal description. So let's maybe ask the LLM. Let's ask ChatGPT what it used to be able to match. So here we've really quickly copied over our query, Instagram worthy, and the recipe, and we're asking the LLM to just explain how did it make this match. And it made the right jumps. So one is it's talking about Instagram worthy because it offers visually appealing and eye-catching snack that would be perfect for showcasing. So it did that. The other leap that it made that maybe wasn't as intuitive is it's saying this is a party snack, and that it implies, so the idea that the actual recipe implies it is ready for a party table, indicating that it is suitable for special occasions and gatherings. So by being part of a party system, a party recipe, it's actually ready for taking pictures because it's going to be generally very nice and suitable for special occasions and gatherings. Let's say you would like to let your users search by an image instead of just free text. So we've got an image of a blue purse, which our user has presented to us. We're going to take that image, we're going to ask an AI service to tell us what's in that image, and then search based on that description. So we've got a blue purse. We would expect to see, oh, yep, relevant results from our corpus that actually sort of indicate and show us results of similar items which are a blue purse. So this type of multimodal experience is really what our users are looking for these days, to see great matches based on what they want, not necessarily everything they were able to type in. Users want us to know a little bit about what they want, even in unrelated circumstances. So we've got a college student here who searched for Japanimation and anime and other type elements in that genre. And let's say that when they go to search for something unrelated, such as school supplies, that we show them that we understand their preferences in a way that are sort of magical. So if a standard user goes and searches for school supplies, they're going to see just standard school supplies. They're going to see, just the normal stuff. But if the user goes and we type in or we add in this user vector, meaning the history of the user, talking about anime and Yu-Gi-Oh and stuff like that, we can blend these types of things and basically push in a little element of our knowledge of the user, the user of the system, to be able to create great results. So now we're showing them user supplies, but notice that there's elements of Yu-Gi-Oh, My Hero Academia, and other Japanimation pieces based on that personalization. So this idea that we're personalizing and understanding what the user wants across the history is now a new capability in these semantic search systems.
So yeah, Nicholas showed us basically the semantic intent and what can you do with a vector database. Unfortunately, he wasn't able to come here as it's 5 a.m. in the morning for him right now, and it's Thanksgiving. Might be one of those two things, not sure. But yeah, so Q&A. Please Nenad, do stand up as well if they ask something. We're not going to read the slides. Any questions? Sorry, the microphone. Thank you.
I would like to ask about the performance of the databases. I mean, about the size of this index.
One of the sizes of these indexes that he showed, one is around 100,000 documents, I think, and the other is around 500,000 or maybe even 1 million documents. I'm not sure. Don't quote me on that. But performance-wise, as I'm working on vector databases, it's just crazy fast. I don't know how to understand you. The algorithm behind it is extremely adjusted for it. With ChatGPT and the vectorization behind it, it's really fast. As you have seen, basically in the searches as well on the demo, it's almost instantaneous.
But about, I don't know, many billions of documents, did you try it?
We have tried with, I think the most, don't quote me, is 50 million documents, and it was live 50 million and then real-time ingestion, and we were asking questions with text-to-speech, and it's instantaneous. You basically don't see the difference behind it.
Okay, thank you.
Thank you. Anyone else? Sure.
Thank you.
Sorry?
Okay. Okay, sorry. So my question is, for when the user enters a query, so do you encode those embeddings instantly, like in real time, or you have like
Yes.
already pre-computed results and stored?
We can cache, actually, if there's the same query, but it's basically sent to the model, it gives back the vectors, and then the vectors are passed to the vector database.
Okay.
So the only choke point in the entire system is the model.
Okay.
So if ChatGPT goes down for some of the queries, it might not work. So.
But did you benchmark it? What's like the response time?
It's in America, because it's based on there, and they have much better latency, it's below 200 milliseconds.
Nice.
It's basically, a lot of it depends is on the actual GPT model response time, which is around 20 to 80 milliseconds. So we can't go lower than that.
Okay, thank you.
No worries, thank you. Here?
Did you fine-tune somehow ChatGPT? I mean, I don't know, make your own plugin or just fine-tune based on some data, or you just use raw embeddings from GPT-4 or another GPT model?
Can you ask again? Sorry, I didn't.
Sorry?
Can you ask again? Sorry.
Did you fine-tune somehow GPT model? Because
No,
I mean,
no.
okay.
We just give it the search query, the exact text. So like, whatever, red boots. We send it over and gives back the embeddings, the vectors, and then we just send those vectors to our vector database, and the vector database is like, okay, these are with special algorithm, we just says, okay, these things are the closest to your query, I just give it back. That's it.
So you just use standard GPT like for whatever API?
The model, yes,
Yeah,
for
okay.
embedding. We also use Hugging models, Hugging Face models as well for embedding, but the vector database is doing all the work. We just need the embeddings from those models that the user can pick which one he wants to use. The better the model, the better the response and the results.
I'm sorry that is all the time that we have for questions, but please feel free to.
We can talk later.
Thank you so much for your participation.
Thank you.
Thank you so much.